Good morning, very good
So,
morning.
a very good morning to everyone. I'd
So,
welcome all the students who are attending the webinar organized by Adichunchanagiri College along with Department of Mechanical and Tech with Mech Club. Firstly, I welcome our beloved principal, Dr. C.T. Jayadil. Welcome to you, sir. I welcome our beloved HOD, Dr. G.M. Satyanarayana. Welcome to you, sir.
Thank you.
Welcome the speaker, Mr. Riyan Mohiyuddin. Welcome to you, sir.
thank you very much.
Now further, not let waste our time. So I request our HOD to introduce today's speaker.
Pleasant good morning to everybody. My dear
Morning.
students, students of AET and students of other college students. I welcome you all to this webinar on topic quality control. First, let us know what do you mean by quality in a simple way. Quality refers to how good something is compared to other similar things. I repeat, quality refers to how good something is compared to other similar things. In other words, it is a degree of excellence. Friends, in today's scenario, all organizations have to face fierce challenge in their business environment due to economic crisis, globalization, as well as a competition in the market. So quality is very important for every business organization. Quality control technique in manufacturing is a procedure that ensures customer service products free from defects and meet their needs, wants, and demands. It is same applies to service also. Quality management and control programs can reduce the cost of product, minimize the waste, and enhance productivity. Imparting information about quality management control is most relevant to budding mechanical engineering students. In this context, we have organized this webinar on this topic, quality control. I would like to invite Mr. Riyan Mohiyuddin to this webinar from the Department of Mechanical Engineering. Let me introduce Mr. Riyan Mohiyuddin. Now, he has completed the mechanical engineering degree from Alpha College of Engineering, Bangalore. Worked as quality engineer in DRDO, the prestigious defense sector in our country. He also worked in GTRE. Then he worked at ACA company, Saudi Arabia, and he completed his master's in process quality engineering from Conestoga College, Canada. Presently, he is working in Toronto Spectral System, Toronto, Canada, as a quality engineer. I welcome you, sir.
Thank you very much, sir. First of all, respected HOD, lecturers, professors, and my dear students, it's truly an honor for giving me an opportunity to come virtually online and present myself about some of the concepts of mechanical engineering and some of the quality tools and techniques that are used in the quality engineering. So it's truly an honor to have me over. I hope my presentation for today's meeting would go out well, and I really hope the students can take all my benefit and get something out of it.
Now, I welcome also our beloved principal of AIT, Adichunchanagiri Institute of Technology, Chikmagalur, Karnataka. I hope he's on the online. Can I request our principal to speak few words on this occasion? I hope he's not in the online. Anyway, once again, I welcome all the students. I hope all students are safe and healthy, but worried about the physical classes and exam. Anyway, let us hope for the best. The thing will be organized soon. Okay, I request Riyan Mohiyuddin, Please go ahead, sir.
Yes, sir. Let me share my screen.
Once again, sorry for the interruption. I would like to thank our faculty coordinator, Mr. Professor Vilas, as well as the student coordinator, Rakshit M. Shetty. Thank you. Please go ahead, sir.
Yes. First of all, are you guys able to see my screen? Hello. Hello.
Yes, sir.
Are you guys able to see my screen?
Yes, sir.
Yes. Okay. All right. Sounds good. All right. So let's get started. First of all, I would like to thank all the students for waking up early at 9 a.m. and getting into this meeting. Just for you to let you know that I'm calling from Canada, Toronto location. Right now the time is 11:30, so I hope I'm expecting this meeting to go on for maximum an hour. All right. So very good morning to one and all present here. So before we get into the quality engineering detail, I would like to just shed some light on the mechanical engineering concepts, because mechanical engineering is the key step to enter quality control. So if you see a simple definition of mechanical engineering, there is a lot of information in Google, in textbooks, in guides, but a very simple and a very logical definition of mechanical engineering is a branch of engineering that concerns with machines and mechanism. It is one of the oldest and broadest engineering disciplines, and it is very well known as mother branch of all engineering. So the next slide is something which defines the different fields or streams that are linked under mechanical engineering. If you see the first one, which is the design engineering or the mechanical design, so this is the very first step in the design, in the introduction of a new product or an existing one. So under design and development, there are various software versions. For example, AutoCAD, SolidWorks, Pro-E, CATIA. There are tons of softwares which are related to design and development. So without a design, a product cannot be manufactured. The next one is analysis and simulation, which is again related to softwares, and this is something where you use the finite element analysis. I think you guys are still in second year, so I think you use about FEA next one or. Then comes the operations, which is sort of the manufacturing or production. It's completely based on knowledge of machinery, mechanisms, production-related tasks, either automotive, oil and gas industry, electrical, electronics, etc. Then comes the quality control. So what quality control means is it is controlling the quality of the product, the requirements or requirements. So QC is needed in every industry, every sector. It's just not mechanical, it is used in every field: electrical, electronics, mechanical, software, automotive, finance. Everywhere you need a QC person for the final product to get approved. So let's get more into quality engineering terminologies. A simple definition of quality, as the principal or the HOD mentioned about quality, even the simplest definition of quality is it means fitness for use. Anything which is fit to be used has to be good, which means quality. Then let's move on to the next definition, which is the quality control. So it defines it is a procedure or a set of procedures intended to ensure that a manufactured product or performed adheres to a defined set of quality criteria or meet the requirements of the client or customer. So your customer requests for something, you make it right, you make sell it to the customer. That's quality. QA/QC is an important field that is associated with all departments within the organization. It's just not related to one department. QC and QA or QC is associated right from the sales department, purchasing, design and development, operations, manufacturing, customer service, applications, sales, etc. All departments. QC is a standard acceptable to the customer. And next one is to discover flaws or variations in the raw materials process in order to ensure smooth and uninterrupted production. Next, the boxes, the blocks, what you see here, it's called as SIPOC. It's either SIPOC or SIPOC. So S stands for suppliers, I stands for input, P stands for process, O stands for output, C stands for customer. So in order to make a product, I need to have the raw material from our suppliers, right? So until then, I cannot move on to the next step. So once I have the raw material from our suppliers, I need input. Input could be your procedures, uh, your machinery, anything which goes as an input. Then you use your methods of making the product, which also includes testing, inspection, etc. Then is your output. Output is your final product, which comes out from the production. And the last one is the customer. So in quality, this is a very short form that most of the companies use as SIPOC. And just for you to know, if you guys have any question in the meantime during the slide, feel free to interrupt me and go for it. So the next slide is other steps that are involved in quality control. So basically, there are 8 steps of quality control. Usually, we call it as PDC, C for check, A for act. In the package, we have 4 sections, which is in the problem. So in production, you have a problem, something's not going right. That means your product is damaged, something not right. You have lots of scrap. That's your problem. Problem to determine the causes could be anything, but your target is to identify the root cause. So you can eliminate the problem forever, so that it doesn't recur or occur elsewhere. Your root causes have been identified. You try on improving a design, a plan, a corrective action plan, or an event plan. That's done. You do something to fix the problem. This kind of improves. After you do something, you need to check whether what you did is right or wrong, or whether this has been effective or not. That's called check stage, which is check improvement results. So after you have completed plan, do check. Now you need to make sure that whatever you have done is working. If it's going to help you or the company, so then you need to standardize the procedure. You need to standardize the methods. That's when it's called act stage. So once you have done it, let's to go to the next problem. So this is what this is the very basic concept of quality. So under stages of quality control, some of the very important aspects are the very first one is the incoming inspection. So for example, let's take an example of let's say we have to build a car, right? So in order to make a car, you need lots of components, you need lots of parts from your suppliers. So when you receive the parts from your supplier, how do you know that the parts that are going to come will be good? How do you know it? You just cannot assume to be working fine. So you do incoming inspection. So incoming inspection of raw materials, reference to mechanical drawings, we call it as GD&T, which is called geometrical dimensioning and tolerance. So it has to meet the required dimensions, physical dimensions, visual inspections, any kind of testing, specification sheets, data sheets, visual inspections, etc. If parts are acceptable, we call it as conforming, which means the parts it meets the requirements, it meets within the spec. It's called as conforming in quality. If parts are unacceptable, if something goes, if the parts are not good, if there is a damage, or if it's not looking good, or the measurements have are out of control or not within specs, then we call it as non-conforming parts. So in that scenario, what we do is the quality engineer or the quality manager would present an NCMR. It's called non-conformance material report. You would fill up the information, you would write the problem. What are you going to do with those parts? Are you going to scrap it? Are you going to use as is? Or are you going to rework or going to return to the supplier? That's basically a report, what you generate. and from there you generate a corrective action report on those on that issue. So once your parts are okay, you start building your car, and during the production of the car you need to do inline inspection. So at every stage there will be a kind of inspection which is performed by QC. So until QC approves stage by stage, the production cannot move on to the next stage. If I'm the quality manager for my company, if I don't inspect and if I don't sign, they cannot move on to the next stage. If I don't sign, they cannot move. So that's the main role of QC. QC is very responsible, is very important in every step by step and every stage by stage. The last thing is the outgoing inspection. Now you have manufactured or built your car. So now you need to make sure whether your car works or not. So what you do is you do final testing. So you make sure your IC engines, your internal combustion engine is working fine. All the parts, the piston is working, the crankshaft, the crank lever, everything is working completely okay. And your hello. Oh, sorry. So do I have to go back? Yeah. Sorry. Taha, do I have to go back to some of the slides, or are we good? Sure. This one? Okay, sure. All right. Yeah. So these are the 8 steps of quality control, what we just discussed. And moving on to the next one, as we discussed here, incoming inspection, inline process inspection, and the final inspection. So once you have built your car, now you need to make sure your car is working as per the requirement or not. So you do final inspection. So once you do the final inspection, there are some standards. For example, uh, if it is US, if we are making a car in US, we follow IATF 16949 or TS 16949, ASTM. There are several standards which need to be followed before you sell your car to the customer or you bring the car into the market. So once your final inspection is done and it meets the and if it meets the acceptance criteria, then we'll start selling your product to the customers. Yeah, so that was a very brief introduction about quality. I know you guys are still pursuing engineering, so this I think this information would really be helpful to you to at least have some basic information about quality engineering. So moving on to the next level, which is a personal journey of me in the quality field. So I graduated mechanical engineering in the year 2011, which was from 07 to 01 batch. University was VTU, college was Alpha College of Engineering. And in my BE, I did the project of building the injection molding machine, making the dies, and tests were conducted on the plastic material, on the plastic molded material. And my seminar topic was electroless plating. Then I pursued my master's in process quality engineering in Canada, in Toronto, and it was in the year 2015. And university location is Toronto, Canada. So in 2011, I started or debuted my career in DRDO, which is a defense firm, Gas Turbine Research Establishment Unit. In 2011, as a quality engineer, I worked there and learned with topmost scientists to accomplish various government projects, which included HAL and ISRO projects. So intense understanding of mechanical drawings, softwares used where AutoCAD and SolidWorks were utilized. And over there, I was completely responsible for inspection and quality control of aero engine components and various mechanical aspects, such as heat treatment, sheet metal fabrication. High-end machinery was utilized for inspection. So there is a machine which is called 3D CMM. This, if I try to recall, this machine costed the Indian government to buy from UK. It was worth 4.5 or 5 crores. That machine costed 5 crores back in 2011. So it's called 3D CMM. It is used to measure the geometrical features of any product or any part to meet the drawing requirement. Over there, I was also responsible in learning some of the basic knowledge of ISO 9001 standards. Instruments were used such as caliper, vernier caliper, micrometer, pin gauges, go gauge, no go gauge, understanding the resolution of the equipment. So your first experience is very important to decide your career plan. So this is up to you guys. Whichever field you try to intend to move on, that's very important for you to decide your career future plan. After working in India for a year, I moved on to Middle East, which is in Dammam, Saudi Arabia. I worked there as a project quality engineer for the Middle East region, handled several customers like Saudi Aramco, SABIC, SEC, etc. I was responsible for inspection of the OEM components of parent company at various customer locations, implemented or drafted ITP. ITP is called as is known as inspection and test plan, and their procedures for testing purposes. Inspection of gas turbine systems were done in order to fulfill the international standards such as ASTM. ASTM stands for American Society for Testing and Materials. Then we have then I implemented some of the quality tools to determine the root cause of the problems. Standards used were MIL, ANSI, ASTM, etc. So as a quality engineer, I was also responsible there for maintaining the BOM. BOM means not the atom bomb, but BOM means the bill of materials. So after working in Saudi Arabia, I decided to pursue my higher studies. Then I came back to India for my visa purposes, and I moved to Canada. I completed my master's in process quality engineering, as I mentioned in the previous slides. And after I graduated in 2015, I started my Canadian experience as a quality engineer. In 2015 in the electronic manufacturing of carbon monoxide sensors and mechanical machinery and mechanism. So quality tools used for inspection, understanding the drawings, writing ECN, ECR, which means engineering change notice or engineering change request, ISO implementation, adhering to national or international standards. Certifications used in North American region are CE, UL, CSA, Canadian Standards Agency, etc. So QC final approval to ship the product out the door. So unless, as I said earlier, unless and until the quality guy doesn't sign on the final document, the product cannot go out the door. The company cannot sell the product outside the company to the customers until the quality is approved. So quality plays a very, very critical, a very important role in the manufacturing of any product. So it could be either from pin to a plane. I was also sent to Chicago for training on ultrasonic welding machine, which is the manufacturer's location. Hands-on experience on assembling the machine parts. So when I joined the company in 2015, the scrap rate was 5 to 6%. So which means that the company was losing $5,000 every day, which would be $150,000 in a month. That would be 75 to 80 lakhs Indian rupees in a month. So within 2.5 years, using the quality skills and the quality techniques, the scrap rate was brought down or was reduced to less than 0.5%. So the company saved $4,500 a day, which was very much close to $20,000, $80,000 was saved every month. So that's how a quality plays a role in as your HOD mentioned at the very beginning. Quality minimizes waste, enhances productivity, and improves the product. So that's how this is a very good example for you to understand how quality can control the product, can reduce scrap, can enhance productivity. So after that, I was promoted as a quality manager in a different company. It was a manufacturing of electrical components. So I was responsible there for the managing quality matters, quality metrics, key performance indicators, writing the procedures, customer complaints, drawing reviews, mechanical, electrical wiring diagrams, NCMRs, corrective action requests, supplier audits, visiting different companies for auditing their procedures, making sure they are following their procedure, they are using the right tools or equipment for inspection, uh, auditing their production side, internal audits of my own company and external audits as well. In addition, I was also responsible for health and safety regulation, because in Canada and USA, health and safety is a must. We are very, very, we are very, very serious about health and safety. I was also responsible, so quality department would also be responsible for measuring equipment. You mean, for example, if you have to measure the resistance, or if you have to measure the temperature of something, how would you know whether the meter that you're using is calibrated or not? It could be deteriorated or it could be damaged. So in that case, there is a procedure which needs to be followed. The equipment has to be the equipment must be calibrated with reference to national or international standards. So it could be either ISO 17025 or NIST. There are many standards which need to be implemented. So once the equipment has been calibrated, the calibration agency would issue a certificate which states that the calibration was done on so and so date, and it is valid for a year or for 2 years or 3 years. It depends on the usage and the physical condition of the equipment. Then I moved moved my career as a quality and technical services manager or head of quality in the plastic industry. I came to my engineering project. Excuse me, there is I think this, please mute whoever it is. Hello. Hello. Yeah. Yeah. Sorry. Right. So moving on, then I moved to another company. I was given a job offer of a quality and technical services manager or head of quality. So I was responsible for control the incoming and outgoing product, implemented procedures for injection molding machine, which included molding, machining. For molding, we had multiple injection molding machines. For machining, we had CNC machines. Fabrication, we had fabricating machines. Then incoming inspection or testing of raw materials, the plastic which came through the standards such as CSA, testing pipe fittings ranged from 2 inches to 4 inches, which is used for water or gas application. So the pipes we were manufacturing in my previous company. So the pipe size ranged from 2 inches to 24 inches in diameter. And those pipes were put inside the gas tank, and a procedure of AA was followed to make sure that there is a criteria that the pipe has to be inside the water tank at so and so pressure and so and so temperature for so many days, and we just try to see if the pipe breaks out due to pressure or not. The AS codes are D2530, D1593, 1594, etc. There are like hundreds of AS stands. There I was also responsible for preparing the inspection test plan from incoming till the final outgoing inspection. There were 2 people who were reporting to me. One was the quality technician, one was the quality supervisor. So I'm also a certified ISO 9001 lead auditor from BSI, British Standards Institute. So I have the license to go to any company and audit their process or their manufacturing procedures. So my current title is quality manager, and my current company name is Tornado Spectral Systems, which is in Toronto, Canada. So over here, I'm helping this company in registration ISO. Really, they are desperate to get ISO certified from my back experiences. They want me to implement procedures and make sure they get ISO registered. I'm also designing and developing their product, their existing new products as well. I'm making sure that the verification and the validation activities are also being taken care of. I also write procedures for of final products, which we call it as factory acceptance, which gets sent out to the customer, and several meters where there is and measured fitness. Product is shipped out the door if it is not performing. If the product is not meeting the required criteria, we cannot ship to the customer. We cannot sell bad products until and unless the product is retested or remeasured, and if it meets the acceptance limit, then only we ship to the customer. Until then, we don't ship. As I said earlier, unless and until a quality guy doesn't approve, it won't go out. And also, I'm also responsible for certifications of ATEX, atmosphere explosibles. So this is one of the major requirement for us to be ATEX certified in order to sell the product in the European market. Also CE marking, CSA, RoHS, REACH compliance, NEB, EU, European Union declaration, etc. All these are standards that are used in electrical and electronic components. So product quality issues, which means customer complaints, quality matters, monitoring KPIs, key performance indicators, monitoring scrap rate, monitoring NCMRs, corrective action requests, customer satisfaction, everything which relates to each department is handled by quality. So I'm also responsible for the quality management system program and quality planning in the form of inspection and test plan of the existing and new products. Supplier audits to ensure they are compliant to their SOPs. I visited USA, New Jersey for auditing one of the company. It's called Nexel. They manufacture laser. They manufacture laser for which goes into the spectrometers. So they were not delivering good products. Every time we test the laser product, it would fail. So I had to go to their facility and make sure they were following the procedure. They were following the right equipment. The person was trained. The person was doing the right job as he's supposed to be doing. The problem was that the equipment they were using was not calibrated. So that's why they were getting incorrect readings. That was the root cause. So some of the quality tools for analysis or monitoring we use is SPC. It is called as statistical process control, which is used to analyze the graphs. The graphs will help us to see trends or to see the positive or negative trending of the measurements. And also the another technique is CPK values, gauge, RNR, etc. So these are all quality terms. Then we have fishbone diagram. So if I need to identify the root cause of a problem, I need to use this fishbone diagram. So we have check sheets, we have 8D reports, we have Pareto diagram. Minitab 17 is a software uh, used to gather or accumulate all the statistical data. Control chart, Lean Six Sigma. Lean Six Sigma is very important in manufacturing and quality. Lean Six Sigma means you are minimizing waste. Then the inspection and test plan. Inspection and test plan is something which means that quality is defining, or quality department is defining what needs to be done right from the beginning, right from the incoming inspection till the final inspection. Quality has to define, and people must follow the quality procedures that are implemented in the system. If no one is following the procedure, that means you're not making a right product. That means you're making something wrong, you're doing something incorrectly that may affect or that may impact the quality of the product. Also, in order to make sure if the people are following or the people are doing the job right, the quality department conduct internal audits just to make sure that people are following the procedure. They know what they are aware of the requirements. Yeah, some of the career tips I have for you guys are, since you all are still pursuing your engineering, you all need to be need to stay focused. That's the very first step. You need to be determined and persistent of what you're doing. You need to plan your career. Then comes the hard work, and the success rate, from what I think or from what I see, is 99% is your hard work and 1% is your luck. Hello. Hello. Uh, yeah. Okay. Sorry. Uh, we will have the Q&A session. So all the slides that were prepared was a very basics information, because I did not want to prepare something which could be complex or difficult to understand, because you guys are still pursuing your engineering, so you need to understand the very basic simple words of quality. So we can have the Q&A session from now. So if anybody have any questions, please feel free to ask. Even if it is a silly question, I wouldn't mind answering. Please go for it. Hello. Hello. Taha, anybody has any questions? Oh yeah, give me 1 second. Let me open this. Where is it? Where is the chat box? Here. Yeah. Is that a question? You mean quality engineering importance in civil engineering? Okay. Uh, right. So first of all, as I mentioned earlier, quality is used in every aspect. In civil engineering, you would be responsible for ensuring the quality of the product that comes in. For example, if you're making a building, if you have to make something, you need to make sure the material which comes in, for example, the concrete or the sand or the bricks, whatever comes in, it has to maintain the standards. So in India, I'm not sure which standards they follow, but I think even civil engineers do follow ASTM standards or some of the civil engineering standards. So it has a very big importance in civil engineering for quality engineers. So if someone wants to pursue it, it's a very good idea. It's a very good, you can build your career in civil engineering. Okay, the next question is, what is the difference between Lean Six Sigma and Six Sigma? So Lean Six Sigma is something which minimizes waste or reduce scrap. So that's called Lean. Six Sigma is something which can be achieved at 99.99999%. That is called Six Sigma. The uh, in the world we have airplanes, right? Uh, they must be meeting Six Sigma. That means nothing can. That is like it's 1 parts per million, one defect out of 1 million parts. So that is called 99.99 Sigma. That means they cannot go wrong in any way. They have to have a strong, when you see a statistical process control chart, a normal curve, it has to be a very like a peak. The curve should be very peak, and it has to hit the Six Sigma. That's the difference between Lean Six Sigma and Six Sigma. What would be the project to be done in final year for any mechanical institute? Okay, this is a very good question from Karthik Shetty. What would be the project to be done in final year for any mechanical engineering institution? Uh, uh, I would say anything, any project which can be made, uh, um, without any external agency due to the COVID or financial crisis. that should be good. I would say if you can look something into plastic industry, or if you can look something into any kind of machine or any kind of testing or something related to polymers, that should be good with less maintenance or less cost. South Khan, are there specific standards which the entire world needs to follow? Yes, some of the specific standards are ASTM standards the entire world follows. We have CSA, we have NEB, we have ISO, we have uh, 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 UL is one of the big standard in European market. Most of the world, the eastern part of the world does follow the European standards. So those are the specific standards which are common. Explain main standards used in quality control. The main standards that are used in quality control are, first of all, it's the ISO. So that's the big standard for quality management system. Apart from that, it depends on the product what you are making. If you're making a product that needs to be uh, licensed in order to ship to European market or American market, then you would follow ASTM, CSA, all those standards. What could be quality in the field of software engineering? This is from Nayan R. Yes, sorry. Quality control can, in software engineering, quality has a very good scope, where you deal with SDLC cycle, you deal with Python scripts, all software related terminologies. Quality control is required there as well. It's the best way to approach potential which helps in the future. How to verify quality of testing procedures. So when so so when the procedures are implemented, so the procedures are actually implemented during the design and development. Until I don't design a product and I don't develop and make sure it's working as it's supposed to be working, then I cannot say that that procedure is right or wrong. So during the design and development, we call it as verification or validation activities. So if I make if I make a toy, even something twice related something, I need to make sure that the toy is working as it's supposed to be working as it are defined in the requirement specification. So until then, I cannot say that this procedure is the right one or the appropriate one or the appropriate one. So unless and until I have some evidence which states that the product is intended to its purpose, then only we can justify or verify the procedure. Are there any further questions?
Hello.
Hello?
Can I interrupt? Hello.
Sure, please go ahead, sir.
Uh, can you brief on this relevance of quality control in the area of service industries? Because we mechanical engineers, we cannot confine to only the products.
Yes. So quality engineering is also is also responsible for products and services. But for services, there are not many standards that need to follow. So what happens is, I can give you an example. Recently, in my company, we also not only provide product services related to our customers. So our sales, so our applications department is a European market to one of the company to customer, and we had some issues with the product. So there are no standards for servicing unless and until you are a very big company like you are Google or you are Bosch or you're very big company and you have money to spend, you have money to buy standards on servicing. So in that case, you just go back to the history, you go back to the quality records, you look back to your delivery information, product number, the serial number, you see if that part had any issues at the time of manufacturing or production. So that would be my answer. Yeah. how COVID-19 impacted employment rate of mechanical. So COVID-19 has impacted the whole world. It's just not India or America. It has impacted uh, every bit of the world. People have lost their jobs. In Canada, 7 million to 8 million people have lost their jobs. In USA, 12 to 14 million have lost their jobs. In India, people are already jobless. It's really bad. So it's just not mechanical engineer who has been affected. It's all industry except software. Software companies are still working because they have the option of working remote, right? So they can sit in even in the bathroom, or they can sit anywhere and work. So that's the advantage they have. Whether quality control needs design aspects. Yes, quality control needs design aspects, right? Quality engineering writes procedures for design and development. So unless and until a product is not designed and developed, how can a company hire a production or a quality engineer? As a quality control manager, what is your management style? As a quality control manager, what is your management style? So my management style is to uh, to to put the right person for the right job, and uh, get the work done correctly, even if you're taking 5 minutes extra, but do it right. That's my management style. uh, how should one make a transition from engineering role to a more business profile? So if you graduate as a mechanical engineer, and if you like to build your career as an employee in any of the company, then it's your decision. But if you have a business or a family business which is entitled to become more of a businessman, then it's your decision. You cannot compare apples with mangoes. So you need to if you want to become a businessman, then you have to become a businessman. But if you want to build your business or start your business of mechanical products, then it's a good idea of doing it. What quality improvement strategies can you suggest to Indian standards? So my recommendation is for improvement of quality as per Indian standard is to be more sensible of writing the procedures, to ensure that the products are not shipped to the customer without it's being tested. You cannot let go your products out the door if even if you suspect 1%, then even then you cannot ship your product to your customer. So implementation and improvement, continual improvement of the products is the recommendation for to come to full Indian standards.
Hello.
Yeah. What some Chinese companies are least scared of? So Chinese companies are least scared of the quality control because they want to make money. If if you make a a, a quality product for 100 rupees, and if a Chinese company make the same product, same design, same look, same performance, same uh, uh, style for 50 rupees, and people would go for 50 rupees because people are not worried about quality. They want less money. They want to buy the same thing for a cheaper version. iPhone, Chinese people are also making the duplicate version of iPhones for 70% less the cost of iPhone of the original iPhone phones, because that's to attract people. So I would prefer quality, not quantity. So even if you buy something worth a good money for a good amount, but the quality is good, it's worth buying. What are the basic foundations of mechanical engineering? So for mechanical engineers, you need to have a strong uh, understanding of thermodynamics, a strong understanding uh, of fluid mechanics, a little bit of heat and mass transfer, mechanical vibration. That because we don't use all of engineering in our job. We use 80 to 20 engineering because depends on the company. If I'm making something which is related to mechanical engineering but it is relevant to electronics, I have to learn, adapt, not implement all engineering in this company or in this product. So you need to know a little bit of everything. Sure. Okay.
Hello?
Oh, yes, sir. Go ahead.
Yes. No, the Indian companies, is it they are following this quality control, the procedure compared to the over
Right.
highway?
So what happens is, right, any Indian company, the ISO, if any company is ISO certified, every external auditor would come to the company to audit. But in India, there are a few companies, procedures, the auditor is not bribed. The auditor does his job honestly without any uh, any support or any activity. But from my experience, from people who have worked in top companies, uh, people the auditors are bribed just to pass the audit. In that case, the people are least bothered to follow the procedures. So what happens is that it impacts the quality of the product to the customer. Is completely spoiled, destroyed, doesn't work, stops in few days. This is the current condition. Hello. Yes. So people south. Someone has asked. He's in third year of mechanical engineering. He has done Six Sigma yellow belt. Work to go with green belt. Yes, please go ahead. Uh, First is yellow, then green, then is black. Even I'm a black. I'm a lean Six Sigma black belt. So it's a certification which is good for your which adds resume. So it is a good option. Please go ahead with further certifications. Yeah. So any other further questions? Any question?
No, Riyan, are you from Chikmagalur?
ಸರ್ ಇಲ್ಲ ಸರ್ ನಾನು ಬೆಂಗಳೂರಿಂದ ಬೆಂಗಳೂರಲ್ಲಿ ಹುಟ್ಟಿರೋದು.
Some said
ಕನ್ನಡ ನಾನು ಮಾತಾಡಿಲ್ಲ, ಯಾಕೆಂದ್ರೆ ಇದು ಈ ಸಂದರ್ಭದಲ್ಲಿ ಕನ್ನಡ ಇಸ್ ನಾಟ್ ಅ ಗುಡ್ ಲ್ಯಾಂಗ್ವೇಜ್, ಲೈಕ್ ಇಟ್ಸ್ ನಾಟ್ ಅ ರೈಟ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಟು ಯೂಸ್. ದಟ್ಸ್ ಅದಕ್ಕೆ ಇಂಗ್ಲಿಷ್ ಮಾತಾಡಿದೆ. ಆಫ್ಟರ್ ಎಂಡ್ ಆಫ್ ದ ಪ್ರೆಸೆಂಟೇಷನ್ ಕನ್ನಡಲ್ಲಿ ಮಾತಾಡ್ತೀನಿ. ಕೇಳಿ ಸರ್, ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಏನು ಇದ್ರೆ ಕೇಳಿ.
ಹಲೋ ಸರ್. ಹಲೋ ಸರ್.
ಹೇಳಿ ಸರ್.
I am Basarajappa from IIT Chikmagalur.
Okay.
Actually, when I was in engineering, I studied many of the statistical quality control tools like
Okay.
X bar, R bar chart.
Oh yeah, X bar, R bar
NP
chart. Yes,
chart,
yes,
PNP
yes,
chart.
yes.
Okay, are these
Yeah.
charts still in use in companies for quality control?
Right, sir. What happens now is, like, when you studied at that time, there were not many softwares. But now what happens is, so there is a software which is called Minitab. the version 17. So when you input all the information into the software, it automatically generates you graphs with X bar, R bar, CP, CPK, UCL, LCL, all the readings. So you need not do it manually because the software does it for you in today's world. And the software even I use in my company, it is called Minitab version 17.
Will it draw the X bar R chart and check whether the process is under control or not?
Yes, yes. It shows whether the process is stable or unstable. It does show whether it's capable or not. It also shows the normal distribution curve. It shows everything. It gives you all graphs, like hundreds of graphs.
And one more question is, this is general.
Sure.
My worry is if the
Yeah.
companies can't sustain during this pandemic and they are their employees, how can we assure our students that engineering is having future, or how can we convince the parents to join mechanical engineering? What's your opinion about this?
Right. So this is a very, very good question, sir. I completely understand. At this point, people are suffering financially. People have lost their jobs in engineering firms, in many other streams. Honestly, this is something personal. In Canada, people have lost jobs. Even in my company, all our employees, we got 20% salary reduction, but still I have a job. This is temporary, just 3 months to 4 months. But 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 things will change, so you need to have hope, right? Things are going to change, so things will change for good. So maybe this year, maybe for the next few months, it's not a good time. So we have to go through the pain, we have to bear the pain. But I'm hoping by next year you will see uh, uh, tons, a big amount, a huge number of jobs coming in India and outside the market, outside the world as well.
Can we assure our mechanical engineering students that they will have a better future?
Yes, mechanical engineering, as I said, is an evergreen field. If they are mechanical engineers, and if they decide, or if they choose not to stick to mechanical, and if they decide to move on to another field or another discipline, they have still have that option. Because if you're a mechanical engineer, you have many doors open. You can either jump into software, or you can jump into electronics or a production. There is a very good scope for mechanical engineers. Maybe not in, maybe less in India, but outside India, a lot of options. There are so many uh, mechanical engineers in Canada, a lot, especially in US. Indians are ruling USA.
Thank you, sir.
Yeah, you're welcome.
Thank you.
Hello.
Now, during this shut off this pandemic,
Yeah.
the world community is predicting the India will be the next manufacturing hub after the China because of major impact on China. Is it any advantage for India in the manufacturing?
Yes, sir. So honestly, what happens is in India, if you are manufacturing a product, it goes back to a question someone asked me earlier. In India, right? If you're manufacturing anything, it depends on the company whether to focus on the quality, which means if they want to hire a quality engineer or a quality manager to make sure that the product meets the requirements, adheres to the standards. But if they are not bothered of the quality, what they want is to make money, then it is up to the company to hire a quality department or to build a quality engineer or not. So that's completely based on the company's decision. But in general, I would say yes, especially in Chennai, Pune, a little bit of north side, quality control is, they take quality very seriously. So there are, especially in Gujarat as well, in Jamnagar, Gujarat, there are thousands of mechanical companies who are into business, and they take their quality seriously, and they have many mechanical quality engineers working there.
Thank you.
Yeah.
Can I
Hello.
thank okay, anyway, thank you, yeah, Mohiyuddin, for your informative speech. You spoke on quality assurance, SQC, calibration, Lean Sigma, Lean manufacturing, the
Yeah.
importance of procedure, so many things, the importance of thermodynamics and other subjects, very important for this quality control aspect. Then you have clarified some the doubts by civil engineering also. Okay, then you said so many things about the present scenario. Thank you very much. You are the most experienced person in quality control area. Okay, then if your permission, next we'll invite you for this type of seminar. Then I finally thank our Tech with Mech, the Tech with team, as well as I thank our beloved people also. Actually, we missed him. Okay, he's very expert in quality control area, quality
Okay.
assurance. Missed him. He has not logged in. Okay. Anyway, thank you once again, Riyan Mohiyuddin. Thank you,
Oh,
students.
thank you very much, sir. It's an honor. Yeah, I'm honored.
Thank you.
Thank you very much.